So ever since I was a kid, I've been really interested in how we get good at what we do, how we come to be the best, and why sometimes we fail to perform up to our potential. I was an athlete growing up, so up here there are actually some pictures of me. I played in the Olympic development program in soccer for several years. In college, I played lacrosse. And I was not only interested in performing well on the athletic field, but I was also interested in performing well in the classroom. I wanted to know why sometimes when the stakes were highest, when I wanted to perform at my best, I flourished, and why sometimes I just wasn't able to put my best foot forward. And in my research, we ask this question. We ask what happens in the brain and body when we're anxious, when we're worried, when we're fearful about doing something. Why we sometimes succeed and why we sometimes fail. And our goal is to understand how performance breaks down in stressful situations so that we can devise psychological tools and training regimens to help everyone perform up to their best. And recently, I've been very interested in what happens in academic situations. So why students sometimes perform well in the classroom and why they sometimes don't. And I've been really interested in mathematics. Mathematics is interesting because, at least in the US, there's lots of people who fear it. You don't hear really intelligent people walking around bragging about the fact that they're not good readers, but you hear really intelligent people bragging about the fact that they don't like math. Oh, I'm not a numbers person. It's almost socially acceptable. And we've been interested in a phenomenon we term math anxiety, which is a fear or apprehension about math. We've been interested in understanding what it is, where it comes from, how it relates to our academic performance. And the idea is that if we understand something about what math anxiety is, we might be able to change students' attitudes about math and help them perform better. So for a long time, researchers thought that people who were bad at math just were anxious about it. If you don't know how to do something, it can be worrisome. But in my research, we've actually made a different argument. We've argued that the anxiety itself, being anxious about doing math, actually reduces people's math achievement, because when we're anxious about something, it changes how the brain functions to support our best performance. And of course, it's hard to get at that in a testing situation because the anxiety and what people know are all muddled together when someone sits down to take a test. So in my work, we've turned to a neuroscience technique called functional fMRI, where we can actually peer inside the brain. We can almost unlock the hood, so to speak, to ask questions about what's happening in the brain, what's different for people who are really worried about math versus people who don't find it anxiety-provoking. What changes not only when they're performing math, but when they just know it's coming. And the idea is that if we can find some understanding of how anxious people react, how it actually changes the brain when they're performing, then we can start to develop psychological techniques that might help students in school. And so we use an MRI machine. It's pictured up here. And all an MRI machine is really a big magnet. It measures the magnetic properties of whatever's inside it. And in this case, we wheel people in on a gurney. And what we're measuring is the head. Because different types of brain tissue have different magnetic properties, we can actually get a really nice picture of the structure of the brain. An MRI is actually 50 to 100,000 times stronger than the Earth's magnetic field. So really, it's just a big magnet. But with a slight tweak in the technology, we can also get an idea or make inferences about brain functioning in almost real time. And so the idea is that when neurons, when brain cells are active, they need things. They need nutrients. They need oxygen. They need glucose. And the way those nutrients get to the brain cells is through the blood. And when the blood is carrying those nutrients, when it's carrying oxygen to the brain cells, for example, it has different magnetic properties than when it's not. And we can pick up on this with the MRI machine, and we can actually make inferences about which areas of the brain are working the hardest at a particular point in time. So to ask questions about what happens in the brain when people are really nervous or anxious about doing math, we invited students to our lab. We wheeled them into the MRI machine. They're lying on their back. They actually had goggles with a computer screen on them, and so they could see things while they're lying there, and they had a button box so they could press a button, and we told them once they got there, surprise, they're going to do some math. We didn't tell them ahead of time. We knew people who didn't like math wouldn't volunteer to be in our study. No one ran away screaming. And what we did as they're lying there is they could see the computer screen. We told them sometimes they were going to do some math problems and sometimes they were going to do a word problem. But we weren't so interested in what they were doing as they actually did the problems. What we wanted to know was what happened in the brain when we just told them they're going to do math. So to do that, we told them that sometimes they'd see a cue. Here it was just a yellow square. And students knew when they saw that cue, it meant that they were about to perform a math problem. One like this, where they had to tell us whether the problem was true or false. Anyone know? False, right? It's anxiety-provoking from some. I see you shaking. So they have to tell us if it was true or false. Sometimes they got a different color square, blue square. And here they knew instead of doing a math problem, they were going to do a word problem. And in this problem, they had to tell us whether if the letters were reversed, it would spell a real word. So this gets close to spelling the word experiment, but not totally. This is a psychologist's idea of a joke, right? So we had people who were really nervous about math and people who were not so nervous about math. They were lying in the brain scanner. They'd get these cues that they were going to either do math or word problems. And what we were interested in is what happened in the brain, specifically for these anxious folks, these folks who are anxious about math, when they just knew the math was going to come up, and how that related to brain activity when they were actually doing the task. So I actually want to show you some indices of neural activation. And what we showed just as a precursor is that for those people who are most anxious about doing math, they showed activation in areas that are consistent with essentially almost a neural alarm signal, if you will, areas that we know are involved in negative emotional processing, and this related actually to their math performance. Okay, so here are a couple of pictures of brain images that we looked at, and what we showed is that the more math-anxious people were, the more likely they were to activate the cingulate cortex, that's in this top picture. And if you're looking at my brain, you've just taken off the left hemisphere and you're looking in at an area called the mid-cingulate cortex. And they're also more likely to activate the insula. So if you're looking at my brain and you're the doctor, pretend you're standing behind me, you've just sliced the top of my brain off and you're looking in bilaterally at an area called the posterior insula. And what we showed is that the more math-anxious people were, the more likely they activated the mid-cingulate cortex and the insula in response to just a cue that they were going to do math. They hadn't done any math yet, they just knew it was coming. And why do we care about these areas? Well, it turns out that the insula and the cingulate cortex are actually activated when we are in pain, when we stub our toe, when we prick our finger with a needle. These areas seem to be involved in our neural pain matrix, and what we're showing is that highly math-anxious individuals, when they just know they're about to do math, are activating areas of the brain that have been involved in threat detection and pain, and the more they activate these areas of the brain, the less likely they are to use important frontal resources of the brain when they're actually doing the math task, and the worse they perform. So we've started now to paint a picture of how the anxiety itself, even before you get to do a math task, changes how the brain is functioning in anticipation of the task than when you're actually performing the task to affect your performance. So it's not just that math-anxious people are bad at math, but we think something about the anxiety itself essentially robs them of the brain power in the moment to perform at their best. So if we know this is the case, this suggests that if we are going to help people perform at their best in math, not only do we have to focus on content, on teaching students math, but we have to focus on the anxiety as well. And so we've been investigating different psychological tools that students might use in school to ensure that when they get to the table to take the test, if they are anxious about a particular subject, they're able to perform their best. And one is actually pretty simple, but is based now on our understanding of what happens in the brain. And it comes from a long line of research in clinical psychology, where researchers have shown that when people are depressed, they tend to ruminate, they tend to worry. And this robs them of the brain power they need to think at their best. And one thing that's really good for getting rid of these ruminations is journaling, just writing your thoughts down. And we thought, well, what would happen if before someone took a high-stakes test, someone who was anxious about math, who knew they were going to take a math test, what would happen if we had them write about their thoughts and feelings? We talk about it as a brain dump, really getting all these thoughts and feelings out in a way that might suppress those negative neural activations and allow people to perform at their best when it matters most. So we invited students into our lab. Some, again, professed to be really anxious about doing math. Some were not so anxious. We told them once they got there, surprise, you're going to take a math test. But before they did it, we asked some students just to write for about 10 minutes about their thoughts and feelings about the upcoming test. We really just told them to have basically a free response, that no one was going to see their writings. We just wanted them to get their thoughts and feelings out. Other people weren't allowed to write. They were just asked to sit quietly. Then we looked at everyone's performance on a math test. And what we showed is just that 10 minutes of writing helped reduce the errors that the most anxious people made about doing math. We didn't teach them content. We didn't change how they think about mathematical principles. All we did was address the anxiety associated with the subject they tended to fear. And here's just an example of our data. On the vertical axis is error rate, so up higher is worse performance. And what you can see on the left here is our control group. These were the students who didn't get to write about their thoughts and feelings. The blue group is our low math anxious participants, so these are people who essentially like math. The red group are our high math anxious participants. And in the control group, you can see that our high math anxious individuals perform worse than our low math anxious individuals. But in the writing group, when we just gave people 10 minutes to think about, to write down their thoughts and feelings before the math test, we essentially reduced the errors that this high math anxious group made. And the idea here is that if we can understand a little bit about what's happening in the brain and body in stressful situations, then all of a sudden we've opened a window into thinking about psychological tools for preparing students to perform at their best. And not only students, athletes, people giving talks in the business world. And if you take anything home from my talk today, I'd like it to be this. It's great to think about how we prepare in terms of our skills and what we know. But if we don't address our mindset, our attitudes, anxieties, our fears, we're missing a large piece of the puzzle in terms of ensuring that people perform at their best. So I'm going to end it there. And if you'd like to read more about this work, you can check out my books. Thanks.
Oh, it's me? Okay, I'll talk. I noticed on the last chart that the error bars in each of both the control group and the high anxiety group overlapped, so that is there some significance? Is there statistical significance in that?
Yeah, in the control group, they actually didn't overlap. So people who are math anxious performed significantly worse than people who weren't. But in the expressive writing group, there wasn't a detectable significant difference. The high math anxious people still did a little worse, but not as much as they had when they hadn't had that opportunity to write. And we generally find about a 5 to 6% difference, both in the laboratory conditions and actually in school settings. So we've done the writing intervention in high school settings. We actually asked a group of freshman students before they took the first final exam of their high school career to do this intervention, and we showed that people who were most anxious about the test, their scores on this final exam were boosted about 6 percentage points. They went from a B- to a B+, just as a function of our writing intervention.
Okay. This question is about the relative measure of anxiousness. I was curious, just like in a regular fMRI scan or regular MRI scan, a patient might look like they have much worse condition, but they're displaying less symptoms when you see them walk into the room. So with relation to that, the related question is, what other biometrics could be used to validate the anxiety levels of the control groups?
That's a great question. So we often use self-report measures, especially when people are in stressful situations or they're anxious about math, but we do also use physiologically based measures. So we often take cortisol measures, which often manifest themselves. It's a hormone that manifests itself in times of stress. So we have people spitting in tubes. And those measures often correlate very well with our self-reports. We often do galvanic skin responses or heart rate as well. So we have a variety of tools that we bring to the table to essentially assess how anxious someone is in a particular situation. But with math, it's pretty easy to get a measure that correlates pretty well with performance. And the question then is, how can we break that link? Oh. The question was, how many people do we usually involve in these studies? So in our study in the laboratory, I believe we had about 40 high math anxious and 40 low math anxious in each condition. In our high school studies, we've done it with several hundred students over several years in a row. And so we are pretty excited about these interventions as a way to help those most anxious students reduce their decrements in performance as a function of stress.
One more.
Yes.
Since you found the fact that there's not just correlation yet causation between anxiety and low-level scores, you think you'll be able to translate that research to other areas, not just schoolwork?
So the question is about whether or not the work that I do can play out in other situations besides school. And I think the answer is yes. I started my work looking at high-level sports skills. So part of my lab is actually a putting green where we bring in really good golfers and we put them under stress. We have people give talks oftentimes in stressful situations. It turns out public speaking is what Americans fear most after death. It's number 2. So there's lots of places where we can study how people perform and how they might fail to perform in high-level situations. And it could be in these situations we think about all the time, like the Olympics or a test or interviewing for a job, but it's also in everyday situations. So the example that I often give from my own life is parallel parking. I'm a great parallel parker when no one's in the car, but when my husband's in the car, I choke.
Thank you, Sian.